All right, what about acceleration? What is the acceleration? Well, the acceleration is the effect of the outside world, or effect of your interactions with the outside world, on your velocity. It is your velocity, not your speed. It can speed you up, it can slow you down, it can turn you, those three things. So this is going to be the basis of mechanics when we talk about Newtonian mechanics. We talked a little bit about it earlier. But that acceleration is a property of your interaction with the world. So it's you interacting with the world, it's how you interact with the world. Whereas the velocity is a property of your motion relative to a way we're measuring the motion. And the position is, of course, also your location relative to whatever we called the origin that we talked about previously. So these two guys are basically, once we've mathematicized our observations, things about you, your acceleration is about the entire world. You interacting with the world. All right. Then, if that's the case, how does this work out mathematically? Well, this is going to be the acceleration is the change in the velocity, just like the velocity was the change in the position. So Bf minus Vi over Tf minus Ti. So this is the directed change in the velocity. Okay, just like the velocity was the directed change in the position. All right, so a negative acceleration, it depends on how you're using acceleration. This is where the ambiguity of language gets us, right? So in a nice, perfect world, we'd say a negative acceleration is to the left and a positive is to the right. Sometimes when we say that, we mean instead a negative acceleration is slowing you down and a positive acceleration is speeding you up. Just for context should tell you which is which. Okay, let's just use for this relative to the origin, right? Relative to the origin, if your velocity is going more rightwards, then it's a greater acceleration. Okay. We also have one other important thing is for uniform acceleration only. That means the acceleration stays the same over the entire time that you're looking at. That would be this Tf minus Tf and Ti. From Ti to Tf over that entire period, your acceleration doesn't change. Then the average velocity is equal to the your initial velocity plus your final velocity over 2. So this is not the definition. This is for uniform acceleration only. So this says if the acceleration does not change. Okay, so remember that's in addition to our other definition of the velocity, which was Vf minus Vi over Tf minus Ti. So that's the average velocity for anything. This is always true. And it is sometimes true that the average velocity is Vf plus Vi over 2, and that's only for uniform acceleration. But this also lets us figure things out without having to do more complex mathematics. Right? Also lets us make more complex mathematics if we want to. If that's what you really want to do on a Saturday night, it'll help you make a little more complex mathematics for you. Right, so that's basically what we have for our acceleration. It's the interaction with the world, and it's going to change your velocity. Right? That's what we want to know. And we have these two equations that relate. Here we have the difference between the initial and final velocities. Here we have the average of them, the sum. So that actually lets us break things down a little bit. And we'll see that in the example, which is just a continuation of the previous two examples. All right? Thanks. Bye now.